We've all heard the story. A single cataclysmic event that wiped the dinosaurs from the face of the Earth. A colossal asteroid, a cosmic assassin, delivering a death blow from the heavens. But is that the whole truth? Are we exposing the asteroid in extinction? Or was it something else entirely? The story of the world's most famous extinction event is far more complex, more dramatic, and more terrifying than a single bad day. To truly understand what happened, we need to rewind the clock. Not just to the day the sky fell, but to the millennia leading up to it. Stick around. 66 million years ago, our planet was a vibrant greenhouse world. A world ruled by giants. Dinosaurs had dominated the terrestrial landscape for over 150 million years, diversifying into an incredible array of forms. From the titanic sauropods to the fearsome tyrannosaurs, they were the undisputed masters of their domain. The oceans teemed with massive marine reptiles like mosasaurs, and the skies were patrolled by pterosaurs. Life was, by all appearances, thriving. But beneath this veneer of stability, the world was already on a knife's edge. The stage was being set for a perfect storm of extinction. And then, it came. An object, estimated to be at least 10 kilometers or 6 miles wide, hurtled through the void at a staggering speed of 72,000 kilometers per hour. Forged in the asteroid belt between Mars and Jupiter, its cosmic journey was about to end in the most violent way imaginable. As it pierced Earth's atmosphere, it would have become a terrifying spectacle, a second sun blazing across the sky, brighter than anything ever witnessed. Its target, the shallow seas of the modern-day Yucatan Peninsula in Mexico. The impact was incomprehensible. It released energy equivalent to billions of atomic bombs, gouging a crater over 180 kilometers wide and 20 kilometers deep. The Chicxulub crater, the immediate effects were apocalyptic. The impact triggered the largest earthquake in Earth's history, with seismic waves rippling across the entire planet. It generated a mega tsunami, hundreds of meters high, that scoured coastlines thousands of kilometers away. Trillions of tons of vaporized rock, dust, and sulfur were blasted into the upper atmosphere. As this superheated debris rained back down, it cooked the atmosphere, raising surface temperatures to oven-like levels and igniting continent-spanning wildfires. For any creature in the line of sight, death was instantaneous. But for the rest of the world, the horror was just beginning. The immense cloud of dust and sulfate aerosols enveloped the globe, blasting climate chaos and darkness. Sunlight was blocked for months, possibly years, plunging the planet into a prolonged impact winter. Photosynthesis ceased. Plants died. The food chain collapsed from the bottom up, and temperatures plummeted. It was a world of darkness, cold, and starvation. This sounds like an open and shut case. So how do we know all this? The evidence is written in the rocks themselves. In 1980, the father-son team of Luis and Walter Alvarez made a startling discovery. At sites around the world, they found a thin layer of clay separating the rock layers of the Cretaceous period from the Tertiary period. This boundary layer, known as the Kapig boundary, contained shockingly high levels of iridium. Iridium is rare on Earth's surface but abundant in asteroids. This was the smoking gun, a worldwide fingerprint of a massive extraterrestrial impact. But the evidence doesn't stop there. Within this same layer, scientists find shocked quartz, grains of quartz crystal fractured in a unique pattern that can only be formed by the extreme pressures of an impact. They also find spherules, tiny beads of glass that formed from molten rock blasted into the atmosphere, which then cooled and rained back down. And of course, there's the crater itself. Buried beneath the Yucatan Peninsula and the Gulf of Mexico, the Chicxulub crater's size and age align perfectly with the KPG boundary evidence. The case seems closed. A giant asteroid hit, the world went dark, and the dinosaurs died. But science says that impact teamed up with other powerful forces that were already pushing the planet's ecosystems to the brink. The asteroid wasn't a lone gunman, it was part of a conspiracy. Meet the second major suspect, volcanic eruptions. But not just any eruption. We're talking about one of the largest volcanic events in the last half-billion years. In what is now India, a region known as the Deccan Traps was experiencing a period of unimaginable volcanic activity. For hundreds of thousands of years, massive fissures in the Earth's crust spewed out more than 1 million cubic kilometers of lava, enough to bury the entire state of Texas half a mile deep. These eruptions weren't just pouring out lava, they were pumping colossal amounts of climate-altering gases into the atmosphere: carbon dioxide, sulfur dioxide, and chlorine. This had a profound effect on the global climate. The sulfur dioxide would have caused short-term cooling and acid rain, while the immense quantities of carbon dioxide led to long-term global warming. The scientific debate rages over the timing. Some studies suggest the bulk of the Deccan eruptions occurred the asteroid impact, pre-stressing the global ecosystem. Other studies indicate the impact itself may have triggered a second, even more violent phase of eruptions by sending massive seismic shocks through the planet. Either way, this relentless volcanism was a powerful accomplice. Then there was the third factor: sea level shifts. In the millions of years leading up to the extinction, global sea levels were in flux. They had been exceptionally high, creating vast shallow seas across the continents. But in the final stages of the Cretaceous, these seas began a significant and relatively rapid retreat. This process, known as marine regression, had dramatic consequences. It destroyed vast areas of productive coastal and marine habitats, which were nurseries for countless species. It also altered ocean circulation patterns and regional climates. This loss of habitat and environmental instability would have placed enormous pressure on both marine and terrestrial life, reducing biodiversity and making ecosystems more fragile and less resilient to shocks. Which brings us to the final element: ecosystems already under stress. Even before the first lava flowed from the Deccan Traps or the asteroid began its final descent, there is evidence to suggest that some dinosaur populations were already in decline. The long-term climate change driven by volcanism and shifting continents was altering their habitats. The loss of the shallow seas fragmented populations. Fossil evidence, particularly from the rich fossil beds of North America, suggests a decrease in the diversity of large herbivores, like the horned and duck-billed dinosaurs in the last million years of the Cretaceous. A less diverse ecosystem is an unstable one. With fewer species to fill ecological roles, the entire food web becomes more vulnerable. If the foundation is already cracked, it doesn't take as much force to bring the whole house down. So let's assemble the full picture. We have a world already being poisoned and warmed by colossal volcanic eruptions. We have ecosystems being fractured and destroyed by retreating seas. We have a decline in biodiversity, creating a fragile house of cards. The planet was already sick. It had a fever and a compromised immune system. And into this weakened world comes the Chicxulub asteroid. It wasn't just a bad day. It was the worst possible event at the worst possible time. The impact winter was a devastating blow, but it struck a world that had already lost much of its ability to recover. The darkness and cold from the impact were compounded by the climate chaos from the volcanoes. The mass death on land was mirrored by the acidification of the oceans, a process started by volcanoes and finished by the impact. In short, the asteroid was the knockout punch, not the first blow. Myth says one cause. Reality is a deadly combo. It was a cascade of catastrophes. This multi-causal explanation is now the consensus among most paleontologists and geologists. The debate has shifted from, was it the asteroid or the volcanoes, to how did these factors interact, and what was the relative contribution of each? It's a story of terrible timing and planetary-scale bad luck. The extinction of the non-avian dinosaurs, along with 75% of all species on Earth, was a profound turning point. It ended the 150 million year reign of the dinosaurs and cleared the way for the rise of a new class of animals, the mammals. In the shadow of the giants, our distant ancestors were small, nocturnal creatures. But with the giants gone, they stepped out of the darkness and into the light, diversifying into the incredible array of life we see today, including us. That's how the giants disappeared. Not with a single bang, but with a prolonged, agonizing groan. A planet-wide systems failure, triggered by pressures from within and delivered a final, fatal blow from without. It's a sobering reminder that life on Earth, even for the most dominant of rulers, can be fragile, and that the history of our world is written by fire, rock, water, and time.